So I don't think we agreed on the name of the talk, but you know, either one should work. But yeah, we're talking about Spark DSLs, not Ash DSLs. But we'll talk about how Ash is related here shortly. So yeah, what is a DSL? Domain specific language is basically a little language that's designed for a very specific purpose. I don't often go around recommending Wikipedia pages, but if you want to learn more, the domain specific language Wikipedia page is actually a pretty good read. And Martin Fowler wrote a lot about DSLs in about 2005, 2006. And a lot of, if you've read Martin Fowler, his writing's generally pretty timeless. He had a bunch to say around that time and it still holds up. So check those bits of writing out. Why do we have DSLs? I mean, basically, because not everyone needs an entire general purpose programming language to write the things that they need to do. So it's a concise representation for a very specific domain. It's minimal to that and hopefully has no extraneous syntax that you get confused by. So by virtue of that, it should be safer. You should have sort of validation and less options to have errors. You can't do everything. It's not Turing complete typically. And so you have expressive power within that domain, which is great. A nice benefit is also it's readable and potentially writable by subject matter experts or domain experts. So potentially non-technical people, depending on the domain. Often the domain is technical, as we'll see in some of the examples. But I think what I want to talk about tonight is how can we bring some of the tooling that we've got to domain experts who may not be technical. So that's kind of the idea here. So what we want really is better, more powerful and expressive abstractions. Because really, what is software about other than creating higher and more expressive abstractions upon previous abstractions? So Fowler did some thinking and classification and ended up making two distinctions. One was an external DSL and one was an internal DSL. Now, the difference is basically an external DSL is a real language without any sort of ties to a host general purpose language. So there's lots of examples here. All of the Unix tools, basically, even regular expressions are basically a domain specific language for text matching. That's pretty great. SQL and COBOL were intended to be, a domain specific language for data fetching in a relational algebra, and COBOL was intended to be a domain specific language for business applications. That didn't really work out, but that didn't stop them thinking that it might when they wrote them. GraphQL is a good example of a modern domain specific language for API specifications. GraphViz, if you've used that, dot syntax for doing diagramming, pretty great. And even HTML and CSS, like obviously they're domain specific languages for content and styling. So lots of examples there. Internal DSLs, really Lisp was probably not on this list, but certainly one of the Lisp ideas was you basically made a domain specific language to solve your problem and then solve your problem in that language. My first introduction to sort of internal DSLs was Rails. Certainly started the whole, metaprogramming, do a decent DSL within the language kind of thing. I think metaprogramming Ruby has its issues. There's a reason that I switched to Elixir and never really looked back. I'm sure most of you are in the same boat. There's a lot of foot guns sitting in Ruby. One of them is method missing with regex arg matching, which frankly still leaves me with the cold sweats at night. If anyone doesn't know what that is, it's basically you can trap any method that it doesn't exist on a class, and you can trap it, and then you can regex match. And Rails, particularly Active Record, use this for lots of magic code and method generation, which you couldn't even figure out where the code lived unless you knew it was there. It's kind of terrifying. So not being able to trace where your code is coming from, kind of scary. So, so that's the difference between internal and external. what are the pros and cons? For an external DSL, you need to write your own little language. And that means you've got to do lexing and parsing. You've got to use tools like Lex and Yak. And in Erlang, Lex and Yak, certainly options. There is a talk proposal from Abhishek, who's going to talk about Nimble Parsec, which I haven't mentioned here, but I'd forgotten about Nimble Parsec, but it is a parser combinator as an Elixir tool. Useful, but look, it's a bunch of work. I wrote the original parser that became the absent parser for GraphQL, and it probably took about 3 months of wrestling with Leaks and Yak to follow the spec to make that happen. It was kind of my first Elixir project, so that may have been why it took so long, but it was kind of fun. But yeah, there was a bunch of work going on. So internal, really basically what it's using is the language itself. And I think Elixir particularly lends itself towards safe DSLs that have most of the power that an external one has. Some compromises. We'll see what it looks like. There are some examples of DSLs that should be familiar. Plug, not so much. I'm not sure why I put that there, but Phoenix routes. If you look at the router, there's definitely, you know, a DSL for configuring and specifying routes and routing. You could argue, and I have done so, that Phoenix really is just a collection of convenience macros over plug. You know, because you could write all of the functions yourself. It's just doesn't look quite as nice. So, you know, routing is the domain there. Ecto, again, there's two styles of, you know, writing queries in Ecto. I think the more DSL-y one is the, you know, from you as user, you know, that kind of thing, rather than the pipeline style of syntax. And Absinthe, that was all done with macros. And yeah, that's a DSL for configuring your GraphQL scheme in Elixir. So this is certainly a new page in the Elixir docs, and it's actually worth a read. It talks about just, you know, how, well, the 3 styles of DSLs that you can build within Elixir. And you can do that, you know, I think they replicate, if I remember correctly. You can look at the page in a minute. But there's basically, they're replicating how we build tests in Xunit. So that's worth a read as well. But macro-based DSLs in Elixir have some issues. There's not one way to do it. So there's a bit more code, quite a few more decisions to make, and quite a bit more complexity. And yeah, you do end up with a bit of a special snowflake because it's not quite the same as everyone else's approach, which makes it harder to maintain, slightly harder to test. And you end up with something that isn't standard and different to every other approach. So we'll see how Spark solves that problem. You get a whole bunch of utilities that aren't there. Basically, formatters for DSLs, typically we like to leave off the parentheses. That is a thing that you have to set up in the formatter. So leaving off the parens actually makes it feel a bit more like a DSL and makes it a bit more readable, less functiony. And you don't also get support for hints about how to write your DSL from the tooling available. So there's no Elixir LS support out of the box. If you wanted to add that, you'd have to make it for each DSL that you made. So what if we could build Elixir DSLs that felt as close to external DSLs as we could make them without writing macros? Does that sound attractive? Well, enter Spark. That's the project. You can see that it came out of Ash. It was actually originally part of Ash Core. So it is driving all of the Ash ecosystem. So why Spark? It really solves all the problems that we've just talked about. It's easier and safer. You don't need to write macros, which honestly is blissful. And I remember 8 years ago when we started talking about Elixir at this meetup, the first rule of macro cloak was, yeah, don't really write macros. it's kind of hard. It's kind of annoying. You can do it, but leave it to the experts. And so being able to have the power of macros without having to write them is quite pleasant. The key thing about Spark is it lets you generate a standardized data structure. So you can focus on designing your DSL to solve the actual problem rather than wrestling with, well, how do we, set this up? What are the structures? And so we avoid ending up with a special snowflake. Spark is all about extensibility. And so a big part of how it's used in Ash is that you can come in and extend things like the data structure DSL or the resource DSL and extend it with various parts of yourself. Now, I'm not going to cover extensibility today. I'm just going to give you sort of the hello world and the basics, but it is a core part of its philosophy. And so there's more to what I'm going to show tonight. Another key feature is just, hooking into all the tooling that you're going to need. So autocomplete, hover documentation, integration with the Elixir language server is really, really helpful for DSLs that are actually easy to use. Because reading the docs, well, it's nice if the docs come to you rather than you going to them. So yeah, as I said, it started as part of Ash Core, and then I can't remember the exact history of this, but me and Zach were talking, and I was like, "Oh, why is this even in Ash at all?" And then he pulled it out, and I was like, "Oh wow, there's a whole DSL maker inside of this." Like I said, it powers all of the Ash ecosystem, so the extensibility gets really used there. And I think it's worth pointing out that it is very well battle tested, but the docs need some love. And certainly in putting together this talk, I've got quite a few changes and potentially bug reports I've got, but that doesn't mean it isn't ready for prime time because it powers all Ash. So it was split out relatively recently, so 18 months ago. So yeah. What are some examples? Ash, clearly a big one, and the entire Ash ecosystem, all of the Ash extensions are driven through Spark. Cinder is actually a kind of like a Phoenix web framework replacement, using Spark to drive, really DSLs everywhere for routing and all sorts. James Harton, who wrote Ash Authentication, working on that. He hasn't published it yet, but it is certainly interesting. Phoenix Channel Handler, Dorgan, who wrote Sorcerer, wrote that. It's a nice little example of a DSL to handle the complexity around handling Phoenix channels. It's quite kind of neat. Seed Factory and James also wrote a thing called Smokestack. So they're both like fixture creators in the style of sort of Ex Machina and Co. for creating seeds for your app. Seed Factory, I think, is just specific to Ecto. Smokestack is Ash resource aware, so it will basically use all of your declarations around your resources in Ash to generate fixtures for you. It's kind of cool. Reactor is a in progress but getting there workflow orchestrator that's going to replace Ash Flow, which is how a lot of the Ash internals are implemented. So yeah, there's quite a lot of examples out there. There's might be more than that. But let's look at the basic concepts. The main ones are DSL section and entity. So the section is, you have to have a section at the top level. You can hide that with top level true. So you can either have an explicit, have to call it top level section, or you can say top level true, and then you don't have to sort of hidden, basically. Sections are singletons, and we've debated whether we even need the split between section and entity. So if it's confusing, it's not an unfamiliar feeling. Because as soon as we started talking about it, I was like, do we actually need to have two different types here? There are, and we may fix it, but there's a lot of work to do to merge the two, not in Spark so much, but in Ash, because it's using that everywhere. The difference is you can have more than one section, but they all get merged together into one unit effectively. And sections can have nested sections and entities. Entities cannot have sections within them, I think. So entities are basically repeatable list items. They can nest each other. And yeah, we're thinking about merging them, but there's lots of impact on Ash. So those are the two things to keep in mind of how we're doing this. So let's have a look at a demo. I should have set this up before. Give me a second. How's the sizing? I need to figure out how to move this video thing. There it is. All right, let's move that out of the way. That isn't helping. All right. Everyone read that? So this is the DSL we want to create. It's very simple. We're just setting up quizzes. It's quite contrived, but this is something that you can imagine your domain expert is a teacher and they want to configure quizzes, in a textual format, and this will let them do that. So we're going to build the DSL to create this. Now we've got the test on the left, the test on the right over here. So let's just go through how we structure this. I'm going to go to top level section here. So I'm starting at the bottom. We use module attributes simply because it's easier and works with how the macros compile. So we have to start at the bottom because we reference the top ones. So I'm going to go from the bottom to the top. So what we start with is our top level DSL section. We're calling it quizzes. If I wanted to hide that away, we can set top level to true. And then we say what entities can that contain. And we reference the module attribute quiz, which is just up here. And that is a DSL entity. We've called it quiz. We've got some description, some examples. We'll see how this helps us in a minute. We need a module to target, which has a struct in it. And so we've defined that. Up here, we've just got a def struct with the things that are the fields that are going to be in there. So let me see, we've got a quiz with a name, a type, and some questions. So we'll see that we've got, wait, that's a question. Quiz has name, two args, name and type, and we've got entities inside, which are the questions. And this schema is actually a Nimble Options schema. Has anyone used Nimble Options? So it effectively lets you describe options for command line interfaces and what have you. It's basically types and required and some docs and the name of the field. So that's kind of handy. And what we can do is create positional arguments out of the name and the type. Otherwise, they are defined by default inside of the section. So yeah, we could actually say over here, that could be, what's it called? The name of the quiz. And this could be SA inside the body. But by using args, we've made them positional arguments. All right. And so that's the quiz. And then inside the quiz, we have questions. So we've got question, another description, and examples, and we'll see how that works in a minute. There is a way to define snippets. I couldn't get that to work, so I've left that commented out, but there should be a way. We're targeting a question thing, and that's just a module with a struct in it. That's sitting here somewhere. So we've just got a title for a question. And it's a string, it's required, and there's some docs there as well. So this is the test, and this is how we use our DSL over here. So there's a module called exam. We use Spark Quiz, which was the module that we defined all this stuff in. And that lets us start defining our DSL. So we've got quizzes at the top level, quiz and questions. And that's pretty much it. What we do get here is some docs. So all of the description and examples and all of the docs that we typed in on the left side allow us to do stuff like this. Now that should have been configurable with the snippet, but I didn't know what the magic incantation was, so I'll have to figure that out. But having that doc around this is super helpful, because otherwise it's very difficult to know what options you've got and so forth. So when you're defining your DSL, you definitely want to put all of this kind of stuff in so that we know how to use it. And then you get inflow help. Now, one of the main ways to see what this produces is the Spark DSL config function. So basically what you get out of that is a large bit of sort of lots of housekeeping within a persist key. And then we get effectively a structure or a nested set of structures that we define in our DSL with the data in it. And so what we're asserting is that when we go and get an entity called quizzes, that it looks like this. And so that's pretty much it. So that's the hello world of Spark. Any questions so far? So a key part of what we get out of this is a introspectable data structure. And this is probably not quite so obvious here, but I've done a little example of just how we can introspect things. And I think for anyone who's used GraphQL, and understood how the schema is defined, and then you can introspect it, and all of the tooling that comes out of being able to introspect a standardized data structure, you can start seeing the power of that. Ash is probably a good place to find examples of where that's useful. We can introspect things like resources to create diagrams like .viz diagrams or mermaid diagrams of domain architectures and entity relationship diagrams and that kind of stuff. When Zach and I were sitting down talking about our training at Elixir Conf, I was like, oh, it's really hard to understand and read and visualize the Ash policy authorization because Ash allows you in a resource to describe, well, who can access this and when. And it's, relatively easy to read, but hard to visualize exactly what's going to happen. And he said, well, it's going to be pretty easy to introspect the DSL there and create a diagram to have a flow chart of who can access what and whether it's going to be allowed or not. So those are the kinds of things you can do with introspection. So what we've got here is I've written an introspection function, which just takes a quiz and then literally creates, a formatted string based on the quiz. So all we do here is take the quizzes that came out of our standardized data structure, call the introspect function over it, and we check that it generates the string that we cared about. Now that could be a diagram, it could be, HTML or what have you. So lots of ways to transform that. What I haven't covered is things like transformers and validation. There's other facilities within Spark to do, change the structure from what's defined in the DSL to something else in the resulting data structure. That's pretty much all I've got. Any other questions or any questions?
I've got one actually.
We've got one in the room.
Okay, room first.
No, not unless you do your own introspection step to turn it into code. Then you'd be, yeah, effectively. So no, it doesn't go directly into code, no. And I think the great irony of what we saw on the left, and if you had been sort of feeling the same way I did when I was writing this, I was like, why am I configuring a DSL using struts? Which is precisely what we were trying to avoid doing in the first place, because structs aren't particularly useful, because you could just write the struct yourself, but that isn't particularly readable or writable or consumable by less technical people. So what you're trying to do is have something a little bit more approachable and a little bit more readable. And structs do not give you the same kind of facilities to do, the hover help and they give you something, but not all of it. And so, yeah, the irony was, well, we're having to construct the DSL using the tool that we're trying to avoid. So there is actually a PR that someone had started, and it's about taking the struct style thing and turning it into a DSL itself. So I think really the end goal, once we get that PR in, is making sure that we can write DSLs in a nice DSL, so it's sort of bootstrapped. Because yeah, like doing it that way, it's not quite as nice as doing it in a nice DSL. What was the online question?
There's one in chat by Mike.
Yeah, I was just wondering, do you get any compile time or build time errors if you leave off a required field or you fail to use the correct type? Does it tell you
Uh,
immediately, or do you have to like try and evaluate it and then it blows up?
the answer is yes, but it may not be quite as pleasant as you might imagine. So I think I had tried leaving off, say, a question. And if I run the test, I don't think I got satisfactory errors. Yeah, this didn't feel particularly good to me. So yes and no. I think that isn't really what you want to see. This is a lot better when we pass a thing and we get a much nicer error. When it expected a string, it gives you a nice error. But leaving the thing off entirely, it's basically complaining that undefined variable question. So it's basically not perfect, but reasonable where it can actually give you an error. It gives you pretty nice ones. So that's pretty cool. Any other questions?
Yeah, I had one. And although this is not particularly to Spark in itself, but DSLs, when do you know when's a good time to start looking at a DSL to solve your problem? Um, like I said, it's very general, and I do see the elegance of like, oh, anyone can read and write it. I'm just going like, when do you get the light bulb moment when you think, oh yes, this is a perfect time to use something like this?
I don't think there's a good answer to that. And I think my sort of exploration back through the literature, particularly Martin Fowler's articles, but also Paul Graham had written a bunch of stuff around building from the bottom up in Lisp, and not being a Lisper, that is unusual to me. But I mean, I think of Elixir as a bit of a Lisp without the parentheses that I always never really got my head around. Look, I don't know. And I think the fact that Spark is there as a tool and isn't sort of well known yet, knowing about the tool will help you sort of at least think about, well, is this a moment I could use a DSL where potentially non-technical users or, like a general purpose language feels like the wrong approach. And certainly, building data structures up with struts is very workable, but they get pretty unreadable pretty quickly. And so, you know, even that where you've got a lot of data configuration and the domain might be a technical one. I mean, GraphQL is a pretty good example of, schema definition. Non-technical people aren't going to be really doing that. And I think you can think about some of the examples of DSLs out in the wild. Like, why would you use a regex instead of trying to write, text matching code yourself?
Because generally the
Hang on, there's a comment from the audience.
Yep.
I think it's just a few people signing off.
I think he may be talking about the live audience.
Yeah, cucumber and gherkin. It can work, but it doesn't generally. Yeah, I think just to repeat the comment, it's really the true you get a non-technical person to start dealing with DSLs directly has always been a bit of a pipe dream. Yeah. Yeah. And I think where I've seen the benefits of DSLs for non-technical users is less in the writing and modification, and more in the reading and consumption, and they should be able to understand, you know, how an Ash resource is put together, and a security person should be able to come in and look at the authorization of a particular, entity in the system and be able to say, oh, I know who can access this and what rules there are around that. Another big example is the rules engines. It's like if you ever hear someone go, oh, we need a rules engine, it's basically where users are crying out to have some programming power, but you don't want to give them a general purpose programming language. And I didn't put it in this talk, but I did run across MPS, which is a JetBrains tool. It's called Metaprogramming System, I think. But basically, they created a what Fowler calls a language workbench, which was an IDE wrapped around DSLs, and you define your DSLs in your base language like Kotlin or Java, like JetBrains would. And then you have effectively a target DSL language that they were using to do very mathematical things. They were also allowing users within a complex tax or insurance domain to reprogram, tax rules. And instead of programming in Word documents, they were allowed to, program the tax rules in a much better place. So that was sort of an external DSL language workbench. But I think if you look at VS Code, yeah, exactly. So right. I don't know if you heard that, but level designing in games is certainly, low level programmers or not quite programmers, but have enough to run a DSL. To do
Yeah.
design.
It's like the Unreal Engine blueprint kind of thing I've seen that looks like a nightmare, something like that. I think I've seen it. It's a bit like a whole bunch of snakes, like Indiana Jones and the Raiders of the Lost Ark.
Even Lua was kind of a domain specific language for embedding you know, within a greater platform, particularly games, but certainly driving AI and doing level design and doing sort of entity behavior within a game. So yeah, I don't know if that answers the question, but I don't think anyone has a good answer for that question. And I
No,
think,
and I think that helps. Like the way how I think I'm interpreting it is basically trying to make readable boilerplate code almost, where
yeah,
they
I
can
think,
look at it and just get a gist of what it tries to do. And there's a lot of magic, but it makes that code for you.
and that's the point that Nick made. And boilerplate, when you've got lots of it and it's very repetitive and very, I guess, you know, noisier than you want it to be, that's a pretty good sign that a DSL could help.
Cool.